Hello everyone. I'm very excited to be here. It's my first Ceph Alicon, and I'm very happy in Ceph community. I'm Vahideh. I'm a cloud engineer in Digikala for 3 years, and we want to share one of our experience in our production environment. One of our speakers, Siavash, couldn't be present here on site, and he recorded his speech, and I play his part right now, and me and my colleague Somayeh continue the presentation. Thanks for your attention.
Hello everyone, and welcome to our session. I'm Siavash Sardari, Cloud Engineering Team Lead at Digikala. Unfortunately, I couldn't be there in person, and I hope to see you guys in the next events. In this session, we are going to share our experience of designing and implementing the object storage service for Digikala. Before I begin, I'd like to thank DevOps Engineering and Edge Services team at Digikala. This project was a cross-team effort. Okay, let's begin with the agenda. We are going to do a short introduction of Digikala, then we define the problem that we had and we try to solve. After that, we are going to walk you through every decision we made and every step we took for designing the object storage service and the final architecture and configurations that we came up with. And finally, we are going to review the lessons that we've learned through this journey. This was a very exciting experience for us, and we've learned a lot through this project. And finally, we are going to share with you the results that we achieved. Okay, Digikala is the largest e-commerce platform in the Middle East area. You can see many metrics here, but the most important one is the page view. We have more than 80 million page views on a daily basis. This number goes up to 200 million, more than 200 million actually, when we launch a promotion. And each page contains on average 40 images. And those images are the objects that we store and serve in our object storage service. In Digikala and in cloud engineering team at Digikala, we had the experience of using Ceph with OpenStack for block storage, and of course some experience with object storage and Rados gateways too. And after migrating the services at Digikala to the cloud that we provide, we ended up with free hardware with multi-tenancy and sharing the infrastructure between services. We managed to free some hardwares, and we came up with the free hardware. And with our experience with Ceph and the Rados Gateway, the cloud department at Digikala proposed that we launch our own object storage service, so we can deduct the couple of $10,000 bill that the company had to pay each month. Not to mention the growth of the objects. I remember 4 years ago, the amount of objects that we had was more than 3 terabytes of data, but now this number went up to more than 65 terabytes. And the experience that we had and the free resources and hardware that we managed to come up with, we decided to go with this project, and we are going to walk you through the problem definition that we had. This slide shows the objects or the image traffic flow in Digikala architecture. The request goes through the CDN, and because we have many users, they use many devices with different screen sizes. We had to resize the image so our user can have the best experience. And of course, the CDN layer would cache image, but the resized version of the image, and the image resize layer would also cache the both original size and the resized version of the image. Because we have 20 pop sites distributed in network, and the image resize, we decided to go with 8 nodes, both for high availability and improving the performance. The number of requests per second and the page views are coming from the previous promotions that we had, but the last layer, the last but not the least, is the object storage, which is the scope of this session. For the object storage, we are expecting 5,000 requests per second. Of course, for the peak time, and because of the architecture that we have, because we needed to kind of horizontally scale the image resize function, we know that we are going to have 8 duplicate requests for each image. And of course, we said that we had to provide 65 terabytes of capacity. Okay, for the next slide, before we are going through the details of our presentation, I'd like to talk a bit about the load testing framework that we used. This is important, and we are talking about the load testing framework this early because we made every decision based off the result of the load test that we had. We used Locust for the load test framework, and for the dataset we used the actual images of Digikala, which is more than 80 million, I believe, images, and the object size distribution, you can see that in chart, and the most important thing is here that almost 50% of our objects are less than 100 kilobytes. So lots of small size objects, but we do have large size objects too. We do have videos and even large images. We have objects up to 40 megabytes. And we designed 2 scenarios for the load tests. First, a unique request, which help us to load test the base performance of Ceph cluster and Radius gateway, and to simulate the real world requests and traffic, we designed another scenario which has 8 duplicate requests for each image. Okay, I leave the exciting stuff to my dear colleagues Vahideh and Somayeh. Thank you for your attention.
Okay, let me please.
Hello everyone, and welcome to our session.
No, sorry. Okay. No. Should I? Okay. Hello again. I continued the presentation, and thanks for my colleague Siavash. Okay, in this part, I speak about the high-level architecture of our deployment. We have a 3-layer of delivering the object to the image resizer, the node. The first layer is Nginx. We use the Nginx as cache server and the load balancer servers. The Nginx should cover and should answer to 5,000 requests per second. And in the miss request, it delivers all of the requests to Radius Gateway's endpoint, and it should handle the 600 requests per second. And it delivers all of the object to the Nginx with a Ceph cluster. I want to speak briefly about our environment. As my colleague Siavash said, we use from the present hardware in our company. We use from the 8 nodes for our deployment. All of them are HB10G, and we try to use the best one of that. And the software that I should mention, we tested our scenarios in both Octopus and Pacific version. And we use the Ubuntu 20.04 LTS version and the OpenResty to build the required module. In the start of the project, we think about different things. You know, we had a lot of consideration and thought, and we should cover all of them based on our previous experience in using the Ceph as a backend storage of the OpenSX services and using the RBDA. We knew that we should have our custom crash map. Because of the different type of disk, and we have a multi-crash rules, and because of the defining the appropriate failure domain based on the the number of the servers and the number of the racks, we knew that we should custom our crash map. The next things that we knew that we should use the SSD disk as a backend for Valve for getting the better performance from the HDD OSD, and we use it. And we knew that we should separate the public and cluster network to avoid impact of 2 types of traffic on each other. And we did it, and we used the 10G, the bonded 10G interfaces for each type of the network. And we knew that we should defining the OSD memory target to achieve the better performance for both the read and write operation, and we define it based on and tune it based on the size of the OSD disk. And in this step, we ask ourselves, replicated or Erasure code, which of them can meet our requirement and can be a good choice for our company with the target of cost saving, with a more capacity. And after that, we think about that if we want to use from the Erasure code scenarios, we should put our metadata pool in Erasure code on a SSD because of the Radius Gateway cache is done on it, and we think that we should put the metadata on the SSD. And the important question that we ask about it, which kind of data caching we should use. We knew that we should use the data caching because of the heavy load that we have in the peak time. And we think about a different kind of methods. DTRN as documented in a Ceph documentation, or different type of data caching, or a Radius Gateway cache, which of them? We want to answer to first question to ourselves. We compare 2 kind of data pool deployment, one with a replicated and another with Erasure code, as I said. And we have the 3 metrics to choose from the one of these scenarios. We have the average request per second, we have the median response time in milliseconds, and we have the 95 response time in milliseconds. And as you know, the replicated scenario is a fast scenarios because it doesn't have the CPU intensive operation as Erasure code. We had the benchmark of the replicated, and in the next step, we benchmark the Erasure code scenarios with 4+2 based on the OSD failure tolerance and based on the nodes numbers and based on the rack numbers. And they chose this, the chunk of the data and the parity. And as you can see, we achieved two these metrics. And I should notice that in a replicated scenario, the availability capacity is 85 terabytes, and in an Erasure code scenario, the available capacity for us is 170 terabytes. And it's important that I should notice that all of these benchmark scenarios is based on the read request because of our requirement of our company. We have just one time of write all of the object to our object storage, and after that read again and again. And because of that, and because we want to test the real world scenarios, we consider only the read request in our benchmarks. After that we choose the Erasure code, we try to understand the different plugins and techniques and choose one of them and choose the better one, exactly. And at first we try to compare the Erasure as the default plugin in Erasure code profile and the ISA because of our servers processor that we use the Intel. And as you can see, we reached to these metrics. And after that, we compare the ISA because of the better performance with the Erasure with another technique, the Blomroth technique, based on the research that we do, based on the the mailing list, speaking of different clients of Ceph, we decided to compare these two kind of method. And we understand that we can achieve to the better request per second in using the Erasure plugin and Blomroth techniques. And thanks you, and I deliver the presentation to my colleague Somayeh.
Hi everyone, I'm Somayeh Ahmadi, and I'm cloud engineer at Digikala company. At this slide, I want to talk about scaling up to 9 RGW instances. Per our experience, and as you know, the best practice for RGW is applied to RGW services per each node. So we started with 2 and we tested with 3 RGW services, and you can see the result. Also, we tested with 4 RGW services on each node, but we phased to OSD disk I/O. Therefore, 9 RGW services is the best option in our scenario. RGW thread pool size is a tuning parameter that is relevant while deciding CPU core allocation to RGW instances. To identify the most appropriate value for this tunable parameter, we ran a lot of tests, and we found that 2008 and 2048 parameter for RG thread pool size is better choice, and it works for our scenario. At this slide, I explained the data caching layer. Cache tiering is the cache tiering that we deployed our scenario with different multi-cache layers such as CDN, image resize, and Nginx. We reached our targets with them, and so due to avoid complexity, this layer of Rados cache didn't have remarkable performance improvement based on our benchmark. D3 in cache. Cache datasets on the access side, D3 and current 3 caches only 10 objects and its cover object larger than 4 megabytes, so it isn't suitable for us. RGW caching with Nginx AWS. These features add to RGW the ability to securely cache objects and offload the workload from the cluster using Nginx. After an object is exceed its first time, it will be stored in the Nginx cache directory. A request is sent to RGW for authenticating access request. Now I want to talk about Digikala architecture. As you see, and as we said before, we have 8 duplicate requests for each image. We needed load balancing tier for HA, and also we could cache content here. But image resize node would balance requests to all of our load balancing node. We decided to implement a separate cache tier to maximize hit ratio of our cache tier. We choose consistent hashing algorithm methods based on the request URI for load balancing. During this project, we learned a lot about the performance tuning and RGW services. We're using consistent hash ring to select the right backend node in Nginx. We use pre-shared buckets because we deployed multiple times, and with each time we route data on the cluster, but we face inconsistency right performance, so we changed the parameter to 1999. Define multi-storage classes for different scenarios. We are different type of data, and we are different type of data that we have to store them to different type of pool. So we must be defined multi-storage classes. Multi-RGW collocation on mon nodes. On mon nodes, we get better performance than OSD, so we apply multi-RGW collocation on mon nodes, scaling up to 90 RGW instances and RGW thread per RGW instances, and the last one is OSD cache. As you see, we have final results in our project. We have Nginx cache and OSD cache. We use OSD cache as a OSD memory target, but for Nginx cache, we get better performance, as you see, 12 average RPS, and also we have met more than twice of Digikala requirements, both capacity-wise and RPS-wise. But we have a bottleneck, RGW public network bandwidth, because it's shared between image resize and load balancer and cache tiering. Thanks for your attention.
Thanks for your attention again. If you have any question, we are ready to answer you. Yes.
On the page where you're comparing the replication 3 and Erasure encoding,
Okay.
do you know what the object size was?
The object size in our site, as my colleague Siavash said, it tested based on the real scenario. You know, there are near the 50% of object size in our size is the lower than 1 megabyte. You know, and it's around, I think, the 50 kilobytes. And the other 50% is about the different size of the object. For example, 1 megabyte, 2 megabytes, some MP4, you know. And because of our company requirement, we try to test all of them with a real data set, you know, with not any specific size of object, you know. We tested, but we share all of our results based on the real scenario objects. Yeah, it's different from each other. Any question? No? Okay, thank you. Thanks for your attention. It's my pleasure to speak about our experience with the community. Have a nice day.